Hi, Math. I'm Andy. So today, let's take a look at an application problem. One thing to just cover, free falling of an object here on Earth has an equation. The position of the object at any given time t is equal to negative 1/2 times gravity times time squared plus the initial velocity times time plus the initial position. So we're going to use this formula to help us kind of think about objects that are in free fall or objects that have been thrown or shot out of cannons or in this case a person jumping off a diving board. Now just to remind us, S sub 0 talks about the initial height of something. So where was it when it got dropped or shot or released? V sub 0 is the initial velocity. So if you just drop an object, it has a initial velocity of 0, but if you throw something, it's going to have some velocity. And g is the acceleration of gravity. And physics has really determined one measurement of gravity is 32 feet per second squared. So we're going to use that as our gravity number. Now, here's our situation. At time t equals 0, so before we even start our stopwatch, a diver jumps off a board that is 32 feet above the water. So here's my little image. This diver's 32 feet above the water and he jumps off. The diver's going to go up first and then down into the water. The initial velocity of his jump is 16 feet per second. So that's going to be our initial velocity because he's jumping into the air at some relative speed. So we have two questions that are posed to us. First, when does the diver hit the water? So how essentially long does it take for him to jump and then get into the water? And two, what is the velocity on the impact? So when he hits the water, how fast was he going? So first, we'll talk about when the diver hit the water. So where he hits the water, if we think of the position, the water is on the ground. So this diver's 32 feet up, but we want to know when he hit the water. So the position at some unknown time, that's what we're going to find, we're going to say is 0. We want to know when S sub t is equal to 0. Now we're going to use the given equation, negative 1/2. We said gravity was 32, and we don't know what t is, so that's our variable t squared. We're also told that it was 16 feet per second was our initial velocity. So I'm going to use 16 for that v sub 0. And this diver is 32 feet in the air. So I'm going to put S sub 0 as 32. So I have my equation, negative 1/2 32t squared plus 16t plus 32. Now I'm going to solve this for 0. First we'll do some simplifying. So this is going to say 0 is equal to negative 1/2 times 32 is 16t squared plus 16t plus 32. So I just simplified the negative 1/2 times 32. Now I notice that there is a common factor of 16, and also my t squared is negative 16, and because I want to deal with a positive t squared, I'm going to factor out a negative 16 from each term. So this would say 0 is equal to negative 16 times t squared. Because I took a negative 16 out, I'm going to have a negative t. Because I took a negative 16 out of 32, I'm going to have a negative 2. So again, what I'm doing is I'm solving the problem for what time does he hit 0. Now this is a trinomial that can be factored. I need those two numbers that multiply to make negative 2 and add to make negative 1. That's how I think about factoring. And so I get, I'm going to have my numbers are going to be a negative 2, so t minus 2, and a positive 1, t plus 1. So I now have set this in a way that I can solve for t. And I know my zero product property says that when you have three terms being multiplied together and you get an answer of 0, one of those terms has to be 0. So I can say that either the t minus 2 term is equal to 0 and t equals 2, or I can say the t plus 1 term is equal to 0 and t equals -1. So I have two times that this diver takes to hit the water, but one of these times is unrealistic in our only positive time world. So I'm going to say that it takes the diver 2 seconds to jump off the board and land in the water. -1, this diver's not jumping backwards in time. It doesn't take him -1 seconds. It takes him 2 seconds. And so this is just unrealistic in our application of this problem. So now I know when the diver hit the water. Now I want to know how fast was that diver going. So that actually comes into a calculus style need to solve this problem. What we need to do is we need to figure out what the velocity of this diver is. And I know that the derivative of a function is the function's velocity. So again, the velocity function is the derivative of the position function. So really what I want to do is I want to take the derivative, we'll call it dt, of the function s sub t. So I want to take what is the derivative of my function. Now the derivative, another way, we can write it as s prime of t. And what we're going to do is we're going to take a look at this function. So this function s of t is equal to -16t squared plus 16t plus 32. And now when I take the derivative, I can split this derivative into different pieces. So it's like I'm really taking what is the derivative ddt, sorry about that. We'll do ddt of -16t squared plus the derivative of 16t plus the derivative of 32. So what I can do is I can actually split the derivative into different pieces. That's the sum and difference rule that is the derivative. Oh, we're starting to get a little sloppy here. So let me help us out. I'll zoom in and I'll try to make this a little more clear, and then I'll zoom back out in just a bit. So I'm taking the derivative of -16t squared, where our power rule says that the power comes down as a multiplier, and then you subtract 1 from the exponent. So we'll say s prime of t is -16 times 2 is -32, and 2 minus 1 is 1, so -32t, plus the derivative of 16t, power rule again, the 1 comes down, so I just get 16, and 1 minus 1 is 0. So I just have 16. And then this is the derivative of 32, and the derivative of a constant is 0. So it turns out that the derivative of my position function is -32t plus 16. So what this means is you tell me the time, and I'll tell you how fast he's going. Now we want to know what is his velocity on impact, and so we need to know when was impact, and we figured that out. We said that it was at 2 seconds. So really what I'm asking here is what is s prime of 2? So I'm going to take 2 and I'm going to plug it in to this function. -32 times 2 plus 16. Now -32 times 2 is -64, and -64 plus 16 is -48. Now this is a velocity, and velocity is measured in feet per second. And so I would say this diver is going negative 48 feet per second. Now, I know it may seem weird that it's negative, but because velocity can have a negative or a positive answer, the way that you can think about this is through our picture. This diver is actually traveling down as he's falling. So because he's going down, he's going a negative velocity. So velocity and speed are the same thing, but because we're talking velocity, we can be specific with direction. Speed is always positive, but velocity can be negative. And so this guy is going negative 48 feet per second as his velocity. Now, that's our answer to our question. The time is 2 and negative 48 feet. But I just want to talk about one more thing just really quick. Let me grab my eraser. So you can pause this if you need to see the work, but I'm going to erase this really quick. And I just want to talk about negative 48 feet per second because that really doesn't mean much to me. I can't imagine that speed or that velocity. So what I'm going to do is I'm going to take this negative 48 feet per second and I'm going to convert it into miles per hour because that's kind of more my speed of how I think. So I'm just going to do a conversion train and then I'm going to do my product at the end. So I know that there are 60 seconds in 1 minute. So that's going to cancel the seconds and turn it into minutes. And I know that there are 60 minutes in 1 hour. And so that's going to cancel my minutes. And so what I've just done by multiplying by 60 over 1 and 60 over 1 was change seconds into hours. And now I want to change feet into miles. I want miles to be in my numerator, and I need feet in my denominator to cancel out feet. And I know that 1 mile is 5,280 feet. So when I multiply my answer of negative 48 feet per second times this conversion factor, again, the seconds are going to cancel out, the minutes are going to cancel out, and the feet are going to cancel out. So my answer is going to be in miles per hour. And so we'll just do that math really quick. 48 times 60 times 60 is 172,800, 172,800. And 1 times 1 times 1 times 5,280 is this. Now this still doesn't mean anything to me, so I'm just going to do one last division. I'm going to put this as a unit rate. I want 1 hour's time, so I'm just going to divide these values to give me 1 hour. 5,280 is 32.727. So this is more of the speed, 32 miles per hour. So this diver jumps off the diving board, spends 2 seconds going up, going down, splashes into the water, and the moment on impact, this diver is traveling 32.727 miles per hour. Thanks, guys.